All right, I'm back. We're still on page 286, and we're on part C. So the question says, let h of x equal f of g of x. Okay, so composition. Show that h of x has a 0 on the interval from 2 to 3. From 2 to 3. All right, so at least that's not the whole table, so that's good. All right, so let's see. If I'm going to show that something has a 0, I'm probably going to use the intermediate value theorem. If I'm going to use the intermediate value theorem, oh my God. I'm going to use the intermediate value theorem, then what I'm going to need is for the function to be continuous. So I'm going to say that h of x is continuous. Am I justified in saying that? I am, because a composition of continuous functions is continuous. But even if I weren't sure of that, because I need to show there's a 0, I would just assert that it is true. Just say it with confidence and maybe people will believe you. In this case, you're justified in saying it, but even if you're not, if you need it to be true, then go for it and hope for the best. So I'm going to say h of x is continuous. All right, let's see. We got to find, basically, I need to find h of 2 and h of 3. So I'm going to do that over here a little bit. So h of 2 equals, so it's going to be f of g of 2. I'm a big believer in showing all of these steps. So g of 2 from the table is 0. So that's f of 0. F of 0 from the table is negative 2. All right, so now I'm hoping that h of 3 is positive, because otherwise I don't know what I'm going to do. So h of 3 is f of g of 3. So far so good, because I haven't done anything. G of 3 in the table is negative 1. F of negative 1 from the table is positive 3. Woo! Okay, we got a sign change. So h of x is continuous. And then I'm going to say that h of 2 is less than 0 is less than h of 3. Therefore, through dot, 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 like dots in a triangle is shorthand for therefore. You can use that all the time. I recommend it. Therefore, h of x equals 0 for some x element of 2, 3. I go back and forth on the like element of and the inequalities. It's like your call. Do what you want, as long as you're doing it right. For some x element of 2 to 3 by IVT. So this actually turned out, like, other than the is h of x continuous, are we even allowed to do it type thing, that turned out to be like the easiest one so far, I think, because it was very straightforward, fortunately. All right, let's look at the next one. W of x, a new function. G of f of x plus 3 halves. This is going to be pleasant. Find an interval in which w is guaranteed to have a 0. Show your reasoning. Whew. Okay, so I'm going to start off with w is continuous for the same reason that h was continuous in the previous one. So w of x, let's do it here. W of x is continuous. All right, now I need to find an interval on which there's a sign change, which means I really need to like find a lot of values. So what I'm going to do is up here, I'm going to add a row to my table. And I'm going to add just g of f of x, because I don't want to also add 3 halves, because I know that I'll be able to add 3 halves. And I don't want to like, I don't want to commit myself to adding 3 halves to a lot of numbers if I don't need to. And I think I don't need to. So I'm going to do g of f of x. So this is like a pro move right here. Adding a row to your table. In fact, let me do it in another color. Adding a row to your table, take ownership, right? Like this is your table and you're going to add a row to it if you feel like it. And you do feel like it. So this is going to be g of f of x. So you're not guaranteed to be able to find g of everything, because we only know between negative 3 and 8. So like some of these aren't going to work out, and that's probably for the best. So for example, if I try to do g of f of negative 3. So f of negative 3 is 1, but I don't know anything about x equals 1. So I can't find this. So that's out. All right, g of f of negative 1. G of, I feel like I did that wrong. G of f of negative 3. F of negative 3 is 1. So I'm trying to find g of 1, and I can't do that. I did that right, I guess. I don't know what I said, but maybe I'm just repeating myself. It's really hard to say. All right. G of f of -1. F of -1 is 4. I don't know any information about 4, so that's out. This is going well. All right. G of f of 0. F of 0 is -2. I don't know any information about x equals -2, so that's out. So far, this is going great. G of f of 2. F of 2 is 3. G of 3 is -1. Okay, but I'm going to add 3 halves to that, so that's really a positive. So like I do need to keep that in mind. So that's actually positive 1/2 when I add the 3 halves. G of f of 3. F of 3 is -1. G of -1 is 4. So when I add 3 halves to that, it's still positive, obviously. So far I have 2 positive values. I don't actually have a sign change yet for this function that we're dealing with. G of f of 5. F of 5 is -3. G of -3 is -2. And when I add 3 halves to that, it is still negative. Okay, that's good. So from what I have here, I know that, what's this function called? W? W of 3 is 4. I'm going to say 5.5. I'll just use decimals, right? It's 4 plus 1.5. W of 5 is -2 plus 1 is -0.5. All right, we're ready. We can use intermediate value theorem on this. So let's go back. And we will say, so I'm going to put these down here also. So W of, I don't remember what they are though. W of 3 is 5.5. And W of, I have no recall at all of what we just did. W of 5 is -0.5. W of 5 equals -0.5. Okay, so W is continuous. W of 3 is positive. W of 5 is negative. Therefore, IVT guarantees a 0. So we are good to go. So since W of 5 is less than 0 is, oh, look at it, just turned into a perfect circle. Can I do that again? It also completely froze this. Oh, it didn't completely freeze it. Did it complete? It did not completely freeze it. False alarm. Can I do that again though? Nope. How close you gotta get to a circle for it to, I don't know. I'll look into that. I'll get back to you, but probably never. All right, it's less than W of 3. Therefore, by IVT, so sometimes I put IVT at the end, sometimes I put it here. You just have to put it. By IVT, W of x equals 0 for some x that is an element. I'm going to go with element of this time, element of 3, 5. So it definitely has a 0. We have found an interval on which we are guaranteed to have a 0. That's awesome. We only found one interval because we gave up as soon as we found an interval because that was the directions. Find one interval and say how many intervals. All right, let me see. What do I have left here? I think I can probably do these. All right, so definition, it's in a box, so it kind of already is highlighted for you. This is a really important definition, a secant line, right? So there's gonna be 2 lines that are incredibly important in your life coming up. There's a tangent line and a secant line. Secant lines are very much an algebra 1 concept. Every line that you wrote the equation of in algebra 1 was actually a secant line. Well, potentially. Well, no, it was definitely a secant line to something. If you are using 2 points on a function to write the equation of a line passing through those, you're writing the equation of a secant line. So a secant line is really just a line that passes through 2 points on a function, right? So it's kind of like when you think back to geometry, circles had secants and tangents, and the secant line passed through the circle. The tangent line just like laid on top of the circle and intersected at only 1 point. Secant line intersected at 2 points. Same thing. So let's see if we can do this. It turns out that they're like a really big deal in calculus. You use them a lot, which is kind of surprising. Find the equation of the secant line to f of x passing through -3, f of -3, and 0, f of 0. All right, let's like write down those ordered pairs. So -3, and then from the table, f of -3 is 1. I'm assuming you have the table in front of you. Otherwise, I don't know. Find the table. And then f of 0, so 0, f of 0 in the table is -2. Okay, so the slope of the secant line, which doesn't have a special notation, unless you want to do this, you might want to put a little secant there. That would be acceptable. I would like seeing that, I think. So I'm going to do -2 minus 1 over 0 minus -3. So -3 over 3, -1. Okay, that's not bad, assuming that's right. And then our secant line. So secant line. You guys want to like label things so that people know what they're looking at. So your secant line is going to be, you can use either point, it doesn't matter which. I'm going to choose to use 0, -2. But I'm going to leave it in point slope form, so like it really doesn't matter. So it's going to be y plus 2 equals, what do we get? -1? -1. Quantity x minus 0. And you leave it like that. That's it. That's your secant line. There's nothing more to do. You are totally done. Point slope form is what you're going to go with. Don't overthink it. Don't do too much. All right, find the x-intercept of the secant line. Yeah, weird thing in calculus, you do a lot of algebra 1, right? Write the equation with secant line is basically like, here's 2 points, write the equation of the line. You find x-intercepts and y-intercepts of those things like all the time. It's weird. Feels like a step back, but that's okay. So x-intercept means that y equals 0, in case you don't remember. So y equals 0. If y equals 0, we're basically dealing with 2 equals -1, the quantity x minus 0. So x equals -2. So the x-intercept, because it's an ordered pair, is -2, 0, 0, 0. You can do it. There we go. I tried like 4 times to put a 0 there and it wouldn't go. All right, that's pretty good. Let's see if we can answer this. Find an interval in which the slope of the secant line to f of x is horizontal. So horizontal secant line. So what if we just like drew f of x? We need a secant line that's horizontal, right? So like this. So this is a horizontal line. What is the slope of a horizontal line? So a horizontal line, the slope is 0. So if I did like f of b minus f of a over b minus a, which would just be slope, I'd have to get equal to 0, which means that f of b minus f of a has to be 0, which means f of b has to equal f of a. If we look at our table, can we find a place where 2 of the y values are the same? So, yeah, I got it. So what should I do? What color? Let's go with this color. At here, right, -1, 3, and then 2, 3. The y values are the same. So I'm going to say, so what did I say? -1 to 2. Since f of -1 equals f of 2, secant line on -1 to 2 inclusive, is horizontal, sorry. I was going to say it has 0 slope, which is the same thing, but you want to like answer the actual question. It's horizontal. There we go. All right. Obviously, we're going to stop here and come back in the next video and do even more. So this is good stuff. This is basics of calculus. Feels a lot like Algebra 1, which is not a bad thing, right? So I will see you in the next video.